Hi, Linda. So, in regards to your question, um, I would like to explain beforehand that most of the problem solving um, skills that you're supposed to gain as you do many of these problems. I think it's easier if someone that has gone through them can sort of like walk you through like the steps. Um, so you don't have to get lost somewhere accidentally, because that's something common when you're barely starting to solve most of these problems. You can go out of tangents and you won't even notice, and you will get an answer and you don't know if it's the right one or not, or what went wrong in equations. So what I would like to say about this beforehand is, first of all, it's always really good to draw a diagram. It helps you visualize what's going on, right? And second of all, um, every data that you have, represent it as good as you can. Represent it numerically and represent it um, in terms of a label, right? In terms of either a variable, if it's changing or it will change in the problem, or a constant if it's not going to change in the problem, right? So we know a couple constants from the problem, right? The volume is 550 centimeters cubed. The cost of the material that it's on the side and on the bottom is 0.02 cents, right? And I labeled that as a cost without the prime. It's always good to write the units, and that the units are consistent as well, because whenever we do calculations, the units have to agree. But that's not something we have to worry about when we're doing with all the algebra. That's just for the end, whenever we are trying to get value, where we care about the units. So, and then, the cost of the top, of course, is a different price. So you label it, you write its number, and then you can write down the formulas that govern the whole situation going on here. Equations that represent constants in the problem, like for example, the volume will not change, right? It says 550 centimeters cubed. So what is the formula of the volume then of a cylinder, right? Pi r squared times h, the area of the base times the height. And you don't necessarily have to solve for this one at the beginning, because you don't know how the problem is going to develop. So just let's keep on writing more variables. So for example, like the side area, or I mean the surface area 1 will be the top one as I labeled on the diagram, and it's just pi r squared, right? And for the surface areas 2, it's gonna be the area of the base plus the side area. And why am I grouping this different areas in different sets? That is because the first area is associated with a different price of the material, while the second surface area is associated with a different price of the material. So it's always good to have this, kind of like think beforehand. Well, obviously we're talking about cost, so we're going to be multiplying the surface area times the cost of that specific material, right? So we want to, sort of like sort things out before we even start writing equations or labeling things. Like, get ready in your head, think ahead of time. What are they asking about, right? What do I need? What do I have, and how do I get it? In terms of, like, of course, mathematical operations, multiplication, division, addition, subtraction, derivatives. Okay. So as for what I can explain, I started right here in the top. The total cost of the material is given by surface area 1, which is the top surface, times the cost of that material on the top, which seems to be the most expensive one. But you don't have to write down the numbers, because then it will be really complicated. Plus the cost of the sides and the bottom, times the surface area of the sides and the bottom part, right? So that will be, you can just substitute everything in there, right? And notice how I wrote CT everywhere, right? CT everywhere all the way until I was here. That's because in all these equations that I wrote, I have two independent variables, right? I have R, which is the radius, and I have H, which is the height. Or actually, I mean, that was the point. That's the point, but I forgot. Anyways, so here is where the H was. So that's where I wrote the T. So all the way up to that arrow that I just drew, that's where you have the total cost. And then after that, you just keep on doing the algebra, substitute for the age, simplify terms, leave everything in terms of a one independent variable, and that's when you can call the cost as a function of R. So now it looks like a function, and now you know what to do with the function, which is take derivatives, right? In this case, which is an optimization problem. So we do have to take a derivative to see how the values of the cost are changing, and see what minimizes the price, correct? So yeah, take the derivative of that, use the derivative rules, group everything that is a constant to the left side to simplify things, and then set up the equation to 0. Why are we setting this equation to 0? Because we're looking for critical points. And remember, critical points are not always the value at which you find the minimums or the maximums. It could be also I'm not sure about what I'm going to say right now, but I think it could be also a point where you can find an inflection point. But I'm not sure you can get those with the first derivative. I think you only get them with the second derivative. Anyways, this could be either a minimum or a maximum. And so usually in calculus, what we do is we test the function right, left, and right, or take the second derivative and see what happens there. But this one is way simpler. Why? Because if you look at the equation when you set it equal to 0, right here, you notice that you can do an algebraic manipulation, right? You can multiply both sides by r squared to get rid of the denominator in terms of the independent variable. But then that will mean one thing, of course. Before you change this, the way you had it before, it means that r cannot be 0. So that's the only restriction or limitation really in this problem right now at this point. So, okay, let's say, well, okay, I don't really need r to be 0. What would that make my cylinder be then? A 0 empty space. And that's not going to solve my problem, because then I'll have obviously no space at all where to even put any substance that I need to sell, right? So, so what you do is you multiply by r squared, right? You get an r cubed, simplify things more, and then you get to an exact value. So there's only one single cube root for this equation. There's no other ones. Worry if you had an even root, in which case you can get more than, obviously, an even number of roots. But when you have a cube root number, especially this third one, there's only one solution to it, right? And so you do the math, that gives you 2.314 centimeters. Again, since everything is in units of centimeters, we don't have to worry about changing any more units. So we're good with that. And then moving to the second page, since we're trying to find the dimensions of this, now that we found the radius, then we can use the volume equation to find the height, right? So the height is v over pi r squared as you solve for the equation, and it gives you 32.7 centimeters. So there you go. That's the answer. I hope this helps a lot.